Hi everyone, in this video we're going to take a slight detour from my normal transmitter based videos and we're going to be looking at the SparkSwitch RS. So what's a SparkSwitch RS? Well, basically it's an ignition switch with some nice features. The unit itself is quite small. I'll just get my ruler here, my steel ruler, and you see it's only about 55 millimeters long, and in the narrow section it's about 20 millimeters, a little bit over 20 millimeters, and the widest section is probably around about 27-28 millimeters there. It's not very thick. Relative to my fingers, you can see my fingers are quite large relative to the unit, so it's quite easy to tuck this unit up near the engine. So typically with ignition modules or ignition switches, we tend to want to keep them up near the engine, near the ignition. And the reason being is we want to isolate the high voltage spark plug leads and the voltages they produce. We want to basically isolate them away from the rest of our avionics. So this unit features optical isolation. So on the right hand side we have a couple of ports there, and they're connected to our ignition module for the engine. There's also a little LED as well. There's a battery, so for the ignition we need a battery. And these ports, basically all these ports are optically isolated from these two ports. So these two ports on the left hand side typically go back to our receiver. And generally we would only be using one port. So if you're using PowerBox, we'd be using the bus port, and we'd connect that to our P2 bus on one of our receivers. And that gets us our telemetry, and basically that also powers up the unit on the input side. So remember that there's basically an output side on the right hand side and an input side. The two are isolated via optocouplers. Again, the reason being is we don't want any high voltage spikes. So for instance, in my Sato ignition modules, they specify 30,000 volts on the high tension lead, on the spark plug lead. So, you know, when the ignition module fires with 30,000 volt pulses, you can actually get RFI basically induced into the wiring. So basically you want to keep the wiring on the right hand side of this unit totally isolated from the left hand side, because the left hand side connects back to our avionics or all our other electronics like the receivers, etc., etc. Whereas the right hand side is connected directly to our ignition module, and you want to keep the two sides separate. So this little device allows us to do it, as it features isolation using optocouplers. Okay, this device here comes in two variants. So the unit I've got pictured in front of us is the 6 volt regulated version. You can also purchase, I'm pretty sure it's the same price, an unregulated version. So this unit here, the regulated version, feeds out 6 volts on the ignition lead. So it powers up the ignition with 6 volts, regulated 6 volts. The unit itself can handle up to 9 volts input, so you can use a 2S LiPo maximum. So that's under 9 volts, of course, and that'll regulate the LiPo voltage down to 6 volts and output 6 volts to our ignition. The unregulated version can actually be fed with up to 13 volts on the input side. So this battery connection, you can feed up to 13 volts on the unregulated version. So basically you could use, say, a 3S LiPo. So it really depends on your ignition module. Some ignition modules need 6 volts. Some require a little bit less. So the 6 volt unit, the regulated version, can do both of those modules. Some ignition modules allow you to have a wider range of voltages. So for instance, the Sato ignition modules on one of my engines specifies from 6 to, I think, 12 or 13 volts. So I could use the unregulated version, or I can use the regulated version with my Sato ignition modules. It doesn't matter. Just something to be aware of. Okay, some of the features. We've got a little LED indicator, so when the ignition module is switched on, there's a little LED that you can connect to the unit, and it basically lights up when the ignition is on. And that's a good safety indication, so you know, when you're working on the model in the pits, you don't really want your ignition to be on if you're flipping the motor, doing some maintenance or whatever. So it's just a good handy visual indication. So it's probably a good idea if you've got a model to mount the LED somewhere that's sort of reasonably well visible. So, you know, you flick your switch on your radio, ignition becomes active, you know, you want to be able to see the LED. It also features, of course, telemetry. And one of the features that it does have compared to the original, I think it was called a SparkSwitch Pro. So the original SparkSwitch Pro was just a switch, on-off ignition switch. That also featured opto isolation, or opto couplers for the isolation. However, this new version, the SparkSwitch RS, also allows us to feed RPM data back to our radio. So we can actually monitor the RPM of our engine. And it basically allows a little bit of flexibility in regards we can use a multiplier or a divider to scale the input if need be. So it really depends on what motor we're going to use it with, how many pulses the motor gives the SparkSwitch RS for every revolution of the crankshaft. And I'll go into that in a little bit of detail later on in the video. Okay, let's maybe connect some wire. Actually, before we do some connections, I might just run through all the ports. So I mentioned the LED. So the unit comes with a little red LED, and you can just plug it into this port. It's just a standard JST connector. You can use any LED. You know, if you've got some high brightness LED, you want to use a different color, they supply red LED. If you want to use something different, you're more than welcome to do it. Just obviously note the polarity for the LED. And the next port, which is on the side here on the bottom, so these are the top ports. The LED is the top port, the bottom port is the battery. So this is your ignition battery. So another important thing is you don't really want to be using your receiver pack to power your ignition module, because you run the risk of getting those high voltage pulses fed back into the rest of your electronics. And the reason being is if you plug your receiver battery pack into here, if you run a lead from your receiver all the way into this port, you basically bypass your optical isolation feature. So you then don't have any optical isolation. So again, I recommend, well, you know, it's highly recommended you use a separate battery. And the battery doesn't have to be big. You know, if you look at the Sato engines, for instance, they basically draw about 600 milliamps, but it only draws 600 milliamps when the spark plugs are firing. So, you know, you can imagine short pulses of 600 milliamps. So you find the ignition battery, you know, doesn't have to be too crazy in size. You can use a relatively small pack. I mean, you can even use like a little inner loop, you know, 6-volt inner loop pack, and that works quite well as well. Okay, moving on to the other ports as well. So we've got the top port on the right hand side, on the side here, is the ignition power. So your ignition module gets power from this port. If you look carefully at the port allocation for the pins, you'll notice the center pin is positive, a bit like a normal servo socket. However, the two outer pins are negative. So they've done that so, you know, if you swap the lead around accidentally, plug it in backwards, it won't damage anything. Just be very careful though that when you're plugging in your battery, the battery's the same. So you've got the two negatives on the outside, positive center pin. Make sure if you're doing a custom lead that you don't get the polarity wrong, because if you plug in reverse polarity on that port, you'll blow the unit up. And there's no coming back from that. One final port on the isolated side is our RPM port. So this would normally plug into our RPM sensor. So some ignition modules have a tachometer output, and you can plug the tachometer output into this port, and then basically that'll convert that to an RPM reading on your display on your transmitter from a telemetry perspective. Now on the left hand side, the optically isolated ports, we have a PWM socket and a bus port. So the bus port is used, for instance, with PowerBox, we use that as a P2 bus. If you're using Futaba, this becomes your S-Bus 2 connection. So basically, if you want to connect it to Futaba, you plug in your S-Bus 2 lead, or S-Bus 2 port is connected to this bus port on the SparkSwitch RS. If you're using Jetty, Jetty uses X-Bus, so basically this bus port connects to X-Bus. And then you've got Spectrum as well. Spectrum supported with SRXL2 connection. So again, run the cable from your RXL2, bit of a tongue twister, port to this bus connection. You do not need to use the PWM connection when you're using Spectrum, Jetty, Futaba or PowerBox. You just need to use the bus port and you connect it to the relevant bus on the system that you're using. Now, if you're using Grobner, Multiplex or JR, you need to use the PWM port in conjunction with the bus port. So the PWM port is basically a standard servo control, if you like. So with Grobner, Multiplex and JR, because their buses aren't really a full bidirectional bus, you need to connect this to a spare servo channel. So you'd use that servo channel to turn this module on and off. And it's just straight plus and minus 100% throw on the channel. Nothing too crazy. However, to get the telemetry back, you also need to connect this bus line back to the telemetry input of the receiver. So you'd have to have two cables. So one into a PWM socket or servo socket on your receiver to control the unit, and one for telemetry. However, like I mentioned before, with Spectrum, Jetty, Futaba, and of course PowerBox, you just run the one lead from your receiver from the relevant bus connection to this bus port. Okay, let's zoom out and let's plug in some cables, and we might even switch on my core transmitter or bind a receiver to a new model, and let's have a look at maybe the transmitter screen as well as some connections to the unit. Okay, I'll zoom the camera out a little bit and let's connect some cables up to the SparkSwitch RS. So first of all, I'm going to use the included LED. So you get a little LED on a bit of cable with a JST connector. Like I said, it's a red LED. So we'll see that light up later on in the video when I activate the ignition module. And like I said, just comes with a standard JST connector. And that plugs into the top port. So if you're looking at the side, it's basically the top port. You can't really go wrong because it's only the only 2-pin port on the unit. And I'll just leave that there for now, but we can have a look at that later when we switch the unit on and off. So one other thing is we need a receiver. So I'll be using one of my spare PBR 9Ds for this example. And we just need to connect the P2 bus. So remember, we're using the P2 bus on PowerBox because that's our telemetry bus, and we're going to plug it into the top port on the left hand side, which is the bus connection. So one thing I forgot to mention is if you're using different systems, so if you're using Futaba, Spectrum, Jetty or whatever, the bus connection, so the bus cable that plugs into there, when you switch the unit on, it automatically detects what system it's connected to, so the user doesn't have to program anything. It's just automatic. So if I plug in a P2 bus connection, as soon as this gets power, it detects that it's got a P2 bus, so it switches to P2 bus protocol. If you're using, say, a Jetty, it'll switch to EX bus, and then you've obviously Spectrum, SRXL2, and Futaba, S bus 2. So that's pretty automatic. Well, it is automatic. You don't have to worry about switching it. Okay, now speaking of switching, the unit itself needs a channel on your radio to turn the unit on and off, to control it basically. And the default that's programmed from the factory is channel 12. Now, if you have a PowerBox or a Jetty radio, you can reprogram that from your transmitter. So later on I'll show you how to do that. So if you don't want to use channel 12, you want to use channel 26 or 3 or whatever, you can do that. However, if you're using a different system like Futaba, you can't control the unit from your transmitter, you can't reprogram it. So at the moment, you need to use the new mobile terminal device that's just been recently released to reprogram this if you don't want to use channel 12. Obviously, if you're going to use channel 12, you don't have to change anything. However, if you want to change it, you need to use the mobile terminal. Later on, there will be the facility to use the standard PC interface to change the channel as well. But at the moment, that's a feature that's not implemented in the PC terminal program. It's only available in the new mobile terminal. So just something to be aware of. Not really an issue for most people, unless you want to change the channel number. Okay, so we've got our bus connection. So ideally, you would never have the receiver this close to the unit. So you'd want this unit mounted up near the ignition module, and you want to keep your receiver and any wiring on the left-hand side here. So any wiring that goes back to the rest of the avionics, you want to keep it totally separate from this side. And the reason being, as I mentioned before, you don't want the high voltage side to be inducing voltages into these cables, because then it can cause all sorts of issues, interference, it can cause microprocessors to lock up, you name it. A lot of people have lost aircraft because of those reasons. So it's just a warning if you're not familiar with these ignition modules. However, for this example, we're not actually going to be running any engine, so it's not going to be an issue for us. Okay, now we also need a little battery for this. So for this example, I'm just going to be using a couple of inner loops. So this is just a 5-cell, typical 6-volt nickel metal hydride pack. So for this example, it'll be fine. And in reality, it would be fine for a normal installation as well. So I'm just going to plug it into the battery port. So remember, the battery port, the center pin's positive and the 2 outer pins are negative. So on this cable, I've only got, this is only a standard servo lead. So I've got a PowerBox connector on it. Well, I really like these connectors. But anyway, I've just got a negative on one of the pins on the outsides. And you'll notice the ports are actually chamfered slightly. So they only accept the standard servo socket in one way only. I mean, you could probably force it in the wrong way, but you just got to be careful. When you make your own lead, you don't want to stuff up the polarity, because you'll let all the smoke out of the unit and it'll be game over. Okay, so that's just our battery connected straight into the port. One other thing to mention while we're talking about the battery is, in the off state like this, the current consumption for this battery is very low. I think it's 1 microamp. It's mentioned in the manual. So 1 microamp, if this battery is connected to it, it'll take many, many months for this to go flat. So don't be afraid to leave this connected and leave it on as it is now. It's not going to go flat in a hurry. The only time you'd be concerned is if this battery was almost dead flat anyway, and then you connect it up to the unit. However, again, it's only 1 microamp, which is a very, very low current draw. What's that? 1 by 10 to the minus 6 amps. So yeah, the batteries will die from old age before they go flat, just about, if they're fully charged. So like I said, don't be afraid. If it's in your aircraft, you don't have to disconnect it every day or every week. Just check your battery every couple of weeks, give it a top up obviously, and it'll be fine. So don't be afraid to leave it connected. That's all it means. Okay, the last 2 ports is the RPM port, and I'll have to zoom out a little bit because I've got a little Sato engine with its ignition module. So I'll just zoom out again and we'll show you the interconnections there. And we've also got the power for the ignition. So the power lead for the ignition plugs into the top port on the side here. And as you can see, we've got the polarities written on there, which I mentioned earlier. So let's zoom out a bit more. I might just pause the video there and I'll zoom out and reframe the picture with the Sato motor in the picture, or in the video I should say. Okay, so now I've zoomed out a little bit more. We can see a few more components of our engine, ignition system I should say, not the engine. So now I've got my little Sato motor here. This is a little FG11, pretty small little gasoline or petrol powered motor, as we say here in Australia. Tend to call it gasoline petrol here down under. Gasoline is not really a term we use here. However, here's our ignition module. So if you look really carefully, there's a warning high voltage indication, and if you look really, really carefully, if you zoom in, it says output 30,000 volts, so 30 kV, and that's passed along this ignition spark plug lead. So this is not really much different to a spark plug lead in your car. And you'll notice the lead's got some shielding on it. So the idea is to prevent any high voltage leakage along the lead. And this is the problem, is sometimes you'll have a loose spark plug cap and that causes noise. And we don't want that noise to get induced back into the rest of our electronics. So that's why it's imperative to maintain optical isolation or electrical isolation between the high voltage ignition system, which is connected to the right hand side of this unit, versus the rest of our electronics. So you can imagine, you have your servos and any other power boxes or whatever connected on this side. You don't want any high voltage, induced high voltage pulses going in there. So again, imperative, always use a separate ignition battery. Okay, so we've got some leads out of my ignition box. So we've got a lead that's connected to the motor. So, okay, what's this? Well, for the ignition to fire correctly, so we want the spark plug to fire, there's a little magnet on the crankshaft pulley here. And basically, as the magnet, there's one magnet, and as it comes past this little sensor, this is what they call a Hall effect sensor. It's basically a magnetic field detector. So as the magnet goes past the sensor, it tells the ignition module to fire, and basically it'll fire a high voltage pulse for the spark plug, and the spark plug then ignites the fuel in the motor. So you can imagine this is spinning around a couple of thousand RPM. So every time it goes around once, the spark plug fires. So this is the output basically from that sensor. So if we look on the actual ignition module, there's a lead. So the sensor has to feed back into the module, and there's a lead. This particular lead here basically connects to here. So I'll just plug it in front of the video here, and that's basically the control for the ignition module. So the ignition module receives a pulse from this sensor, and basically it tells the box to fire. It fires 30,000 volts into the spark plug, and away it goes. We've got two more leads. So one of them is a power lead. So this red and black cable here is a straight power lead. So this is the power that we feed in to power the ignition module. So like I mentioned earlier, this module can accept between, I think it's 6 to 12 or 15 volts. I can't remember I have to look at the handbook again. This unit's a regulated unit, so it just outputs 6 volts, but that's fine. The unit will still work. So we just got to connect that to our ignition module. So we need to basically connect it to the ignition port, which is basically our 6 volts out. So when I flick the switch on my transmitter, this port will power up to 6 volts and feed it into this lead, which then powers on the ignition. Okay, so let's plug the servo plug I should say, servo lead. It's not really a servo, it's an extension I should say, servo extension. And we'll just connect it to the power connector. So that'll provide 6 volts to the module. Okay, and there's one lead left to be connected that's coming from the ignition module, and that's the RPM output or the tachometer output. So normally you can use this to plug into a display that shows you the RPM. However, in this situation we're going to use the SparkSwitch RS RPM input port to basically monitor the RPM on our transmitter. And I just realized, just turn on another light, oops, I forgot to switch on one of my background lights to give us a bit more illumination here. So I'll just turn that back on. Anyway, back to the task in hand. So we're going to plug it into the RPM port. So the RPM port is the bottom port here. And you'll notice the white wire has to go to the left. So I've got to plug in the extension lead in this direction, and let me plug that into the right port. It's a bit awkward when you're using the camera. Okay, so I've plugged him in the right way. Like I said, the main one to be concerned about is the power, input power. You don't really want to get that wrong if you're making your own custom leads. So anyway, this is our RPM connection, and that can be connected straight into the RPM lead coming, or the tachometer output lead from the ignition module. Okay, so everything's connected now. We don't have any power applied to here because the receiver's off, but I might just move some of the gear a little bit out of the way. I might put the core transmitter here so we can have a look at the screen, and also maybe keep these two guys in view as well. So give me a second and I'll rearrange all the hardware. Okay, I've repositioned everything, so we've got the core transmitter screen in the main view on the video, and the SparkSwitch RS is in the background out of focus, but that doesn't matter because all we're really interested in is this little LED here. So we've got the LED plugged in. We just want to see when we switch the ignition on, so the spark switch will apply power to the ignition, this LED should turn red. So we want to have a bit of visual feedback. So the LED is going to be the important aspect in this particular part of the video. All I've done at this stage is bound my receiver to this model, and that's pretty much it. So when you buy one of these SparkSwitch RSs and take it out of the packet, you'll notice, or in the instructions, it says that the default switching channel is channel 12. So we can change that later, and I'll show you how to do it. However, let's set up a channel, our channel 12, of course, so we can use a switch to operate it on. So I might just pick on this switch here. So what I might do is have the switch, so the ignition is switched off in that position, so the LED should not be illuminated. And then when I flick the switch to the center position or to the fully back or forward position, the LED will stay on. And then if I push it away from me to the fully back position, then the ignition should be switched off and the LED will go out. So let's do that. Let's program up a function in my radio. So as you'll notice in this particular model, there's no functions assigned at this point in time. Let's rename it. Let's call it, I don't know, IGN, short for ignition. And we're going to use this switch here, switch E. And we don't need to set up any trim or any fancy curves at this point in time. Now this is where we pick our actual channel that we're going to use. So we're going to use number 12 because that's the default for the SparkSwitch RS. Now we just got to make sure we get the switching around the right way. So at the moment, basically the SparkSwitch RS is expecting plus 100% for on and minus 100% for off. So what do we want to do is I want, when the switch is in this position here, so the fully back position or forwards, depends which side of the fence you're sitting on. However, when I've pushed the switch away from myself, I want minus 100% travel. So quickest way to do that is to, let's reverse this. So now if I put in minus 100, that's the switch position in that position there. So when I flick it to the center position, I want plus 100 because I want the unit to switch on. So I want the ignition to be on, and also for the switch position there, which is towards myself. However, we want minus 100 in that position. So we've got minus 100, easy. So now let's offset the center. So we'll go to plus 100. So in the center position, remember we want the ignition module to be on. So the ignition module is, or the SparkSwitch RS I should say, is expecting plus 100% travel in that position. So if we look at the servo travel there, we've got 0 now because I've offset the center. So let me get rid of the limit, make it negative 200 because I have to make that minus 200. Okay, so a bit of fiddling around with the travels and the center point. We now have negative 100% servo travel in this position. We have positive 100% travel in the other two positions. So the ignition module will be on and then off in that position. Okay, now what else do we need to do? Well, let's switch the unit on, and then we'll also set up a telemetry widget, which we won't be able to use for this example yet, but I will later. But let me apply power to the receiver, and if you wait 1 or 2 seconds, you'll notice the radio is saying 2 sensors found. So basically one sensor is the PBR9D receiver and the other sensor is a SparkSwitch RS. So if we actually make a widget, let's make a widget, a telemetry widget. Let's add a sensor. You'll notice here we've got the receiver, we've got the core itself, and then we've got the SparkSwitch RS. And the only parameter we can monitor is revolutions or RPMs. And we click on OK. We can obviously set up alarms in that. Actually, what I'll do is I'll make that large so it's nice and easy to see for us. And you'll notice the units are U per minute. So I think it's a European standard. So normally we would have RPM, revs per minute, revolutions per minute. However, yeah, U per minute means the same thing. I'm sure Richie could probably sort that out with a firmware upgrade for that. Okay, So we've got our telemetry, that should be working, but like I said, later on we're going to do some bit more technical testing on this unit, and I'm going to take it inside into my electronics laboratory so we can hook up some fancy test gear and all that to mimic some pulses coming in from the engine, so we can actually see what happens as far as the telemetry is concerned. Okay, let's see what happens now. We've set up our switch, so that's operating channel 12. Let's see what happens when I switch the switch on. And look at that, the LED comes on. Now the LED is lit up there. If I switch the switch off, there it goes, goes out, on, off, on, off. Simple as that. So now we've got control of the ignition on our aircraft. And of course you can set up virtual switches, some fancy logic to basically lock out the ignition so you can't accidentally start the engine, or the engine won't fire accidentally. And you can, tie it into your fail safe. So basically, the system goes in the fail safe. You can drive that channel 12 to off. So basically the engine will switch off, all that sort of stuff, which we don't really need to cover in this video. Now, one other thing, while it's powered up, let's have a look at the menu structure, what we can program as far as the SparkSwitch is concerned. So let's go inside into its menu. And you'll notice we've got firmware version 1.0, so it's still got the original firmware. I don't believe there's been a firmware update for these. And you'll notice the next entry is switch channel. So this is where we can change what channel is active as far as what channel you want to use to turn the unit on and off. So if we make it, say, 15, you'll notice now if I operate my switch, the LED is no longer operational because it's looking for channel 15, but we haven't set up channel 15 to do anything. So it's just basically not operational anymore. So if I go back to channel 12, and yeah, you can pick up any channel you like, so from 1 to 26 as far as the core transmitter is concerned. So if I go back to channel 12, you'll notice the LED is now illuminating again, or being controlled by the switch. So that's the ignition on, ignition off. Simple as that. Now, one other handy feature is this parameter called factor, or the factor parameter. So at the moment it's set to 1 to 1. However, we can change it. We can make it say 1:2, 3, 1:4, 2:1, 3:1, 4:1. So what does this factor do? So if you think about a typical engine, I know my Sato motors, they send back 1 pulse per revolution. So in that case, as the crankshaft rotates, you get 1 pulse per revolution. So in other words, in 1 minute, you'll get 60 pulses. So if you're getting 1 pulse per second, that's basically 60 RPM. If you're getting, say 50 pulses a second, that equates to 3,000 revs per minute. But basically the thing is, it's sending 1 pulse per revolution. So because it's sending 1 pulse, there is no scaling required for it to measure, for the radio to measure the RPM appropriately. So you can just leave it 1 to 1. However, some engines or some ignition modules might send, say, 2 pulses, or some might send a pulse every 2 revolutions or every 3 revolutions. So to get the right reading for RPM on our display, you need to set in a factor. So basically the 1:1 is a straight 1:1. There's no multiplication or division done. However, if you've got, say, 1:2, 3 or 4, or if you then go to 2:1, 3:1, 4:1, basically that allows you to multiply the reading or divide the reading appropriately by 2, 3 or 4 units. So for instance, if we were getting only 1 pulse every second revolution, you need to multiply the reading by 2 to get the correct RPM reading. And vice versa, if we were getting 2 pulses every revolution, then, remember it's revolutions per minute. So if we were getting 2 pulses per revolution, you then have to divide the display by 2 to get the correct RPM reading. So yeah, simple as that. but it allows you to do that within the radio. For those that don't have a PowerBox or Jetty radio, the only way to change these two parameters at this point in time is to use the new mobile terminal. So just be aware of that. Later on, the PC interface of the terminal program currently it doesn't have the SparkSwitch RS listed, but that it is coming. So that will be put into the PC version as well. So you'll be able to change, once that's done, you'll be able to change these two parameters with your PC and the USB interface. Or if you've got a mobile terminal, they're a little handy device. I don't actually have one yet, but I'm getting one, and I'll probably do a bit of a review on that as well. Anyway, for now, that's all you need to remember. So this factor is a way of dividing the displayed RPM reading or multiply it, so it gives us the actual correct RPM figure on the display. And that just really boils down to what sort of ignition module and the way they do the timing on the engine. Okay, that's all I wanted to show you in this part of the video. I'll probably stop it at this point in time, and then I'll move all this stuff into my electronics lab area, and I've got some test equipment in that, so I want to generate some pulsars and feed them into the SparkSwitch RS, and then we'll actually have a look at the display and see what it's doing, and maybe we'll take it to a few extremes, like let's have a look, what's the maximum RPM, what sort of signal do we need to actually trigger the unit, because there is a RPM probe that you can purchase that sits in series with the RPM lead, and that's required for certain ignition modules. It's basically a signal line conditioner. It basically it's a bit of an amplifier, also basically can stretch the pulses a little bit. Like I know, for instance, I did some testing with my Sato ignition module, and it has quite narrow pulses, and for instance, if I plug the tacho lead straight into here, it doesn't actually work, and I'll explain why later. And I have to use the RPM probe for it to get a reading on the display. So some engines or some ignition modules you'll need to use the RPM probe, some you don't. Okay, thanks for watching so far, and stay tuned for the next part of the video as well. I'll talk to you all then. Thank you.